Hello, everybody. Um, so let's see here. What is important for this week? So, as you probably know, there were no CTFs this past weekend, and there are no CTFs coming up this following weekend. So, there's not a ton of stuff that's really important to talk about right now in terms of, useful, relevant information. I can't talk about challenges I solved over the weekend because I didn't play any CTF. And I can't go forward and talk about challenges previously for a CTF coming up. So instead, the plan for this week, at least for the Monday stream, is to basically just mess around with some tools. In particular, the Manticore stuff. So Manticore, as you may or may not know, is a tool from Trail of Bits for doing symbolic execution. Manticore. Um, and did... Yeah, Google is learning about me. But Manticore is a tool for doing symbolic execution of binaries. You can think of it kind of like Anger, except not. The differences are primarily that Manticore seems to be intended to be driven primarily by Python scripts. So basically, the intention is you write a bunch of Python to run Manticore over a binary. Whereas with Anger, it's more complicated than that and confusing, and there's so many different interfaces into it, and it's complicated. Anyway, that's the plan for tonight's stream, is basically to spend an hour or two poking at Manticore and seeing, basically spending the time to have me learn how it works better so that I can apply it better in the future. Because if you remember last week on the stream, I tried to use Manticore on some of the challenges from the DEF CON quals. It failed entirely on them, and I kind of just gave up and called it a day. Today I want to go through, I want to learn exactly how to use it, what I did wrong there, try and extend things. So that's the plan for this week. Hello, everybody in the chat. Looks like we have several people right now. Welcome. So that's this week, or tonight. Just so those of you who are watching know, on Wednesday, I'm not going to be streaming. The plan had been to start the Python 0-day work, basically trying to go out and find some new Python memory corruption bugs. However, I've got some other commitments going on Wednesday, so the plan is instead to, on Saturday afternoon, do the same thing. So about 11 Eastern, I think that's 3 a.m. UTC. The plan is to start and do exactly the same thing then. So do some of the groundwork to understand what Python memory corruption bugs look like, and go from there. That's the starting place that I'm going to use is Python Jailbreak? Is that what it was called? No. Yeah. Basically, I'm going to start with the bug that they used on this post and go from there and see if we can write a fuzzer to do that, to find the same bug, see what else we can find, hopefully land several different Python memory corruption bugs. It'd be exciting. That's me on Saturday. The other thing that's important? No. Today I will be definitely streaming. The other thing that is important is if anyone is interested, I decided to play with some of the Mastodon stuff. So it's basically a Twitter clone, and I had an instance stood up. Oh no, I don't remember how URLs work in this thing. How do they work in here? Just a second. Oh wow, this does not like... So anyway, Mastodon is a... Oh, there's an @ sign there. But yeah, so Mastodon is basically a Twitter clone. The idea was, at least as far as I know, to use some of the GNU social stuff, make it more useful, things like that. But one of these is stood up. If anyone would like to, feel free to register here if you want to play with it. Yeah, so I'm thinking the fuzzing the Python stuff. I think the intention that I want to do is I want to start from scratch and actually write a generative grammar fuzzer from scratch, basically just to demonstrate how you would do that. Less about, because I think it's less about the actual bugs we find and more about the process of getting there. So anyway, those are the important announcements type things. I will post a link to this too. That would be useful, wouldn't it? Um, yeah, those are the announcements, if you want to call them that. Um, so let's talk about Manticore. So, like I said before, the Manticore stuff, the basic idea is that you're able to use it to do symbolic execution of a binary. And the basic idea behind that is I can take a binary, take a trace. So I have a program that's executing, and it's following a certain path through the application. And at any given point, I should be able to record what the register and memory state are. And it should be, if I start from that same register and memory state, I should be essentially the exact same path, regardless of how I started that way. What the symbolic execution is trying to do is instead of putting concrete values, so instead of doing, what's a good way to do this? So let's come in here, because what we're going to look at, we're going to look at some of these binaries again. But, so it's roughly equivalent to saying, instead of doing 1 plus 1 is, or 1 plus 2 is 3, I would do 1 plus x is 3, and I'd be able to find all the solutions for that. Symbolic execution is kind of similar in that instead of having a concrete value, what do I need to put in this register to get down this code path, it's able to use these symbolic values instead, with the end result that you're able to do some fancy solving stuff to try and calculate for a path way down this chain, what do I need as the initial input that would get me there? And it lets you do some really cool stuff. One of the better examples is that if I am fuzzing something, so let's say I'm fuzzing a really simple file format, and let's actually, is that getting clipped at the bottom there? Yeah, that looks better. So, where was I? Right. Let's come over here. Maker Manticore. And let's screen this up. So, found include standard io.h. I'm just going to put together a really simple application here, which a fuzzer is going to find very difficult, but at least in theory, a symbolic execution tool should find very easy to solve. And the easiest thing to do here is I'm going to read, so car star buff is equal to, what? Let's do it this way even. OX 20 bytes. We want to do a read standard in. What's the right args for that? Oh, it is the right one. Standard in buff, and I want to read 20 bytes from standard in. And then int I is equal to int star buff 0. I think it works, right? Print if I is equal, that's Python. I don't want to do Python. I have to do modulus. So if I XOR 41414141 is equal to what's something good to put in here? 111111223344. That seems like a real thing. Yes. Did I mess that up? No, that's right. I want to do what's the right way to cast this? I always forget how to declare a function pointer properly. So void f, void star f. Is that right? I don't know if that's right or not. Hello, Ginvale. Wow, there's a lot of people showing up today. This is exciting. But f is equal to, and this is going to break terribly, I know it. So why is my C terrible today? Okay, I missed a semicolon? I did not miss a semicolon. Oh, I did miss a semicolon. Okay, L value is required. That's what I was afraid of. Okay, let's see if I can remember how to cast this properly. Not right. Let's see what Google has to say here. Cast to function pointer. I always have to look up how to do this properly. Not what I want. But that is basically what I put, isn't it? Oh, did I declare it wrong up here? Is that gonna work? I am terrible at this, aren't I? Yeah, the channel is really busy today. I typically don't get this many people. That's exciting. That is what I want to do. Actually, you know what? Let's just do it this way. Void win. You win. CTF, you lose. Right, so clearly the idea here is if this works, then I should be able to... I read from standard in. Why did that not buffer properly? That's not what I want at all, is it? So I'm reading from standard in. Why is that not... CTF sent x, y. Implicit, oh. Am I being dumb about this again? I'm being dumb about this. Pound include unisted.h. Much better. So standard in is 0, right? There we go. That's not quite what I want. I want that. There we go. That is what I want to see. So if I did this properly, I should be able to go Python-C print. Let's actually do this. Because I find using pwn tools for this stuff so much easier than remembering how to do it off the top of my head. From pwn import star print E64 OX4141414141 XORed with OX11223344 plus D times OX1C D D E F. Yeah, that's right. So if I do Python that, not sure why that took so long. That's odd. But see, if we do this, it will print out, I win, and it works. And the idea here is that if I was fuzzing for this, it would take, on average, about 2 billion tries, right? Because I would have to get that I value right. And in this case, that's clearly this is some magic number with a backdoor in this program. But there's all sorts of more realistic things that come up when you're trying to fuzz something. So let's say there's a CRC, or there's some sort of like unlikely control flow path that we'd want to go down. And in fact, the PDF crack stuff that we were doing in the Wednesday streams is kind of an example of this. So I guess for a recap for people who haven't been watching the Wednesday streams, we spent 3 weeks trying to, so we spent a week fuzzing this application called PDF crack, which is apt search PDF crack. Basically, it's just some random PDF cracking software. Info's a thing, right? But there was a show. That's what I wanted. Yeah, so it's just a piece of software for brute forcing a encrypted PDF password. And so the first week we ran it through AFL. AFL fuzzed it for, I think, about a week I spent fuzzing it. We went through and triaged a whole bunch of those results, and we found one heap overflow. Basically, we were able to manipulate, they were basically just reading a string in out of this file, putting it into the heap, and you just completely smash whatever else is there. So that was the second week, was triaging all of those. The third week was trying to do some heap grooming to get everything to line up the way we wanted it to. And then the fourth week, we started trying to actually exploit this. We'd finally overwritten some pointers. We were trying to get something useful out of that. And in the process, I stumbled across a very simple stack smash. It would read in under a very specific set of configuration options in this file. It would read in 256 bytes into a 120 byte buffer on the stack. And AFL never got down that path because the conditions to get down that path were very specific. You needed a 4-byte value in one place, a different integer value in another place, and I think you needed a third one in a third place. And for AFL to find that, it would have to line all of those up in sequence, essentially by random chance. Whereas a symbolic execution tool should say, oh, to get down this path, I need these 3 values to be a certain thing, and then come up with a way for them to be that thing. So, assuming that everything works the way that it should, if I was running AFL against this very simple application here, so we read in 32 bytes. If the first 4 bytes of it, when XORed with A's, is equal to hex 11223344, we win. Just a stupid simple backdoor. Fuzzing this, it would take, on average, about 2 billion combinations, assuming there was no logic to break this apart or things like that. Because it would have to go through and it'd have to try each of those possible values until it found one that just by chance happened to go down this other path. On the other hand, again, actually, let's, I believe there's a dash verbose flag I can use to actually print us out more stuff. Oh, this prints out way more stuff than I wanted. Never mind. I forgot that the verbose flag prints out all of the register state, and that's way too much output. But running Manticore against this, what it should do is it should run twice. Instead of the 2 billion cases that it would take to fall down here, again, on average, it should take 2 cases because it would say, oh, there's one path that takes me down this you lose path. Let's generate an input that does that. And there's a second path that will take me to the win path. And it will generate an input to do that. So, assuming that everything is working properly, the default behavior, as far as I know, for Manticore is that it will do exploration. So one thing that comes up a lot with symbolic execution tools is this idea of um, exploration. I should be able to say, you know what, that's a very good idea. So Mark in the chat, who's one of the developers, just mentioned that the latest version has a bunch of verbosity flags. And really, I should turn those on so that I get not only the verbosity stuff that I wanted, but also so I have all the whatever new features there are. I believe I put that in CTF tools. Is that correct? No. Where did I put this? Home directory tools? Home directory tools. So I should be able to do a git pull here. Ooh. I assume being on master is decent. Do I want to use master or do I want to use one of their tagged branches? Using a tag is probably the best bet. Oh, git checkout. I'm on a tagged branch, and now... Ooh, I'm really curious. If I just... Sure, what's the worst that happens? Let's swap everything out from underneath you. And I'm sure this is going to break everything. Oh, I should be on master? Okay. I will switch to master and do the same thing. So I am positive that this is probably going to absolutely kill this test that's currently running. At least I would hope it would. So I'll be able to do it. Oop, that's capital V. Oh wow, there's so many arguments now. Look at that. Right. So what's going on here is I've now updated to the latest version of Manticore rather than the, what is it now, 2-week-old version that I pulled down last time I did a stream on it. And so what we're seeing here is this is running through. It's doing it's doing a first pass of what exactly does this application do. And this debug output is basically saying, oh, we loaded libc, we read that in, we immapped some stuff in, we had to improtect it because it's a library. It's basically going through that startup process. And now we're waiting a little bit. And ideally, if we sit here, we wait, and we watch this run, what it's going to do is it's eventually going to get to the point where we call that read. So in the program, the first thing main does is it calls read from standard in into this buff. So what Manticore should be doing here is it should say, oh, by default, Manticore assumes that standard in is fully controlled. So it knows that it has full control of buff up to 32 bytes worth of value. It'll then see that copied into I, and then it, well, I guess I didn't need this anymore. It'll see it printed out, which is going to cause it to take a little bit longer than it would otherwise. But then it'll see this XOR, the comparison, and a branch. And so what it's going to do here then is it's going to actually try and figure out how to go down both of these branches, because there's both the left branch, which goes down the failure case. So thinking about branches kind of like, I think most graph-based disassembly does that. That if you're looking at them going down, the projects a.out. So the left branch over here, so we compared this against, oh, that's kind of cute. They, GCC decided to optimize the XOR out. But it's going to go down the left branch here if it does not match, or down the right branch if it does. So what Manticore should be doing here is it should say, oh, this var3c is something we can control. We need to create separate inputs to go down the left branch and the right branch and see where that gets us. So, still running, but now we're actually getting into some more useful things. Unfortunately, I suspect it's probably working pretty hard right now on this printf. We'll see. because my guess is that so one of the things that I was told when I was first working on this in the Manticore Slack channel is that they don't do a lot right now with trying to optimize some of these function calls. So we're calling printf with a value that we control. Let's reset. We're calling printf with a value we control, this I. What that means is that there's all of this code in libc to convert I into into a hex formatted string to print out. So they're going to try and solve through all of that, plus all the branches in that, and try and come up with things like that, which isn't really what I want. I don't actually care which side of that branch you go down. Like, why on earth would I care if you printed out 4 values or 3 values? Don't care. But we can see up here that it found the right to you lose. That seems pretty solid. But we're still working on it. So we have another case for you lose. Oh no, are we going to find a whole bunch of cases for that? Core W. So we currently have 2 inputs that it's been able to calculate. So we have the first one. Ooh, I want the pickle one. I want dot standard in. Oh, I don't want state. I want test. 1.standard in. The first one is they supply a whole bunch of null bytes, and it does something. This next case, it supplies a 1 there for one of the high bits. Presumably what it's doing here is it's actually, unfortunately what I suspect it's doing right now is it's solving through that printf, which is not really what we want to do. So let's see where we get with this. So one of the other things that's quite a bit more useful and is actually super exciting about this is I can use their API. I don't have to just say, go into this and explore. I can actually set up very specific things to tell me get where, like, I want to say that we're going to go at a specific point. I want to know what the values are such that I'm able to get down a certain path. So we wait here for a minute. What do we have right now? We got another input. 3.standard in. That looks identical to that one, doesn't it? That's odd. I wouldn't think it would do that. But ECC test.c. Don't care. Oh, I should probably give it a oh, we still have this open, don't we? Found include standard lib.h. ECC test.c. So we're going to start this over. You know what? I say that, and I went to all that work, and I forgot to remove it. Let's try this again. So what we did here is we removed this printf, so it should be faster now, because it doesn't have to solve through all the libc stuff that was being handled with that. And while we're at it, let's reload this, so we can actually take a look at the proper values here. So this looks almost identical, except that looks actually identical. What? That's not right at all. Save. Okay, that looks right. Are you caching this? No. Okay. I just don't know how to use computers, apparently. That's unfortunate. But where were we? So we should see this comparison, and we should see it, actually work. But while this is running, there's this other piece of it that's equally important. So I want to go and I want to say, rather than just exploring, I already know where I want to go. I want to get to this win path. I should be able to say, I want to get to this call. So 400,672, open a new Manticore s.py from, what's capitalization on this? From Manticore import Manticore. Im is equal to Manticore ./a.out. So we're just loading up this binary. You know what? I'm gonna bring this over so I can actually read it. Oh no. Set no auto indent. There we go. So I want to then do a im.hook. And so what im.hook is doing is this is a decorator in Python. So you can have a decorator for a function. Basically what that's doing is well, let's get this all set up before I explain what that's doing. It's a little bit complicated, especially for somebody who isn't super familiar with how Python works. CPU.read int RBP minus OX34. So I'm going to print out what that value was when I get down this path. Okay, so let's explain what's going on here real quick. So we created this Manticore object. It's a class that they've defined in their library here. We've created an im, which is a Manticore class object. Then there is this decorator here. And what a decorator does is you can create a decorator, which is going to we're going to call im.hook with this argument and this function as an additional argument. So it's roughly equivalent to if we said im.hook OX 400,672, hook as a second argument, except this is a little bit cleaner to write. Like, it's easier to read that than im.hook. Like this, it isn't quite as obvious that this is directly tied with this function definition, whereas the decorator, that very clearly is saying that this call to im.hook is directly tied to the definition of this hook function. Basically what we're doing here is we're saying when PC is equal to this value, we want to hook in to the symbolic execution using that state. Oops. CPU is equal to state.cpu. We want to get the CPU out of that state. We will then want to read an integer value. We want to read an integer value from CPU RBP minus 34 hex, which if we come back over here, that was the value that was being compared. So when we get down this win branch, oh, does the decorator? Yeah, I don't actually know how decorators work. They're kind of magic to me. I'm sure they work differently under the hood, but at least my understanding of them, which apparently is completely wrong, has got me a little ways as it is. im.hookAdder returns an object that has call. Okay, I will totally believe what disconnected says. Oh, okay. So it's not doing this, it's doing that. So not quite what I said, but kind of similar. But so that's what that's doing, and hopefully we got through this. So if we do ls-latr imcore __, we have two different paths. So there were two different inputs that it created. So we have test one.standardin. We have one that was just a whole bunch of null bytes, and then a second one that had that magic value that when we supplied it, it actually calculated that. And if we come in here, we should be able to do python t.py cat.xxd. What? Oh, projects. So I get for having a lot of directories in different folders with similar names and all open at the same time. Right. So we see that it has the first 4 bytes that are exactly the same because that's the magic 4 bytes that we needed to get down that backdoored function. It's just that if I was fuzzing this, I would have to try all of those combinations until I got up to that, as opposed to symbolic execution, which tried 2 values, one that didn't get down that path and one that did. That's the basics of it. There's also the other side of this. So I should be able to do Manticore test.py. Now what this is doing is it's very similar. It's going to do the same thing, except instead of doing blind exploration, I'm saying I want specific pieces of information. So where this would be useful is, say that I wanted there was some comparison. So the example that I looked at to actually figure out how any of this stuff works is this multiple styles write-up by E. Hennevent, which is really great. It's actually a really useful write-up to look through. It actually shows there are 2 very clear different ways to do it. First, you can do the concrete solve, which is kind of what I'm doing. Well, no. So the way that the concrete solve that they're using is they're actually forcing the flag and checking what it's compared to. Because you can treat this kind of like a debugger. I can say that I want to go to right here, and I want to force the jump the other direction, and then see what the compared value was. I can't with this one because because it doesn't actually load the constant into a register. But if it did, I could read out what that register was. But the more interesting one is this symbolic solve, where they're doing something very similar. I forgot to say solve 1. Hopefully that works. Actually, not sure if this script is going to work now. And I also want to do im dot. Oh, look at that. So it did a thing. What is going on here? Why can't I? What are you doing? Okay. Apparently, the combination of Vim and screen has eaten an input. That's unfortunate. Oh, I had caps lock on. That is the worst. Okay, where were we? We have this, so I should be able to say that in imcore PE. Oh, we didn't have any inputs. That's interesting. I didn't realize that it wasn't going to create those. Where's the right window? im.verbosity equal to 1. I think that's the right way to do that. We read an integer, but it didn't actually cast it quite the way that I expected it to. I thought that would work. Print. Let's see how those 2 work. Let's run this again. Again, if all this works the way that I think it should, then it should give me an answer here. And by upping the verbosity a little bit, it should give me a little bit more output so I can actually see what's going on rather than talking blindly as this thing runs. Although it would appear that I'm not getting as much output as I would like. I might have wanted verbosity 2 instead of 1. But essentially what this is doing is it's almost the same thing as when we were just blindly exploring. Except instead of it just being a blind exploration, we're saying that we want to get into a certain spot and then figure things out. So, we get to. that's the basics of it. I'm not sure exactly what, while we wait for this to run, let's think about what the next thing that I want to do is. So, what was the status on this? So, where is it? I want core. Well, this, oh. That value is symbolic. If I want concrete, I will have to solve it. That's unfortunate. So should I just do solve state.solve one? Is that right? Yeah. State.solve one. Let's see how this works. Oh, that did not like that at all. So let's see how that works. Right. So, this is something that I was super excited about. So one thing that I'd really like to be able to do is I would like to be able to take a core dump and load it in. Because one of the problems with using symbolic execution tools, such as Manticore, is that if I'm doing something very complicated, it needs to create a way to go from the start of the application. So let's say I wanted to get down here, and for whatever reason, there's a ton of code in this first block that is super complicated to get through. But I already know how to get through. A good example is, let's say for whatever reason, I was looking at a PDF parser. Not a PDF parser. Sure, a PDF parser is a good example. So I'm looking at a PDF parser, and for whatever reason, I only want to look at one specific chunk type in there. So there's different types of chunks or sections. I don't remember what they call them in PDFs. Each of which is going to have a different function to try and process it. And let's say that I want to get into one of those paths. So one thing that I could do is I could feed in an initial file and get down that path. But based on the way that Manticore works, that may or may not be exactly what I want to do. It would still have to go through the entire first part of the program and understand how all of that works. Or, ooh, there we go. Look at that. It's done a thing. What value did you come up with? That looks like the right value with some extra bytes, because I read 64 bytes, so yeah, that looks like the right thing, doesn't it? So if we go in 3, 2, oh, that is not, oh, 05726350. Yep, that looks like the right bytes. So we can see here, this went through and it did the exact same thing, except we directed it. So what's actually the time comparison there? Time Python Manticore test.py and time Manticore a.out. So I'm just doing this because I'm curious, not because it's going to give us anything useful. Because this, I think, is more specific, so I'd expect it to be faster, as opposed to this, which is more general. I would expect it to take longer. But I don't actually know. So, we go pop back where I was, loading a snapshot. One ability that I'd like to have is the ability to shove in, here is what memory should look like right now. Here is where to start from. Because normally it would start when, I believe it starts when the loader hands off, or prior to the loader getting loaded. That's why we saw like libc getting loaded in there. We had the debug output printing out, which realistically, there's no reason for us to have that. There's no real good reason for our symbolic execution to try and even think about loading in libraries and things like that. One of the techniques that people have used to get around that is, well, let's just take a snapshot of this thing already running. Instead of trying to go from the very start, let's start, in the middle when you're reading in my input. Or maybe even after that. After you've read it in and done the processing, I have a snapshot that says, here is where you should start. So, a feature that I would really like to have is the ability to do that with core dumps, like they already do with mini dumps. And they've had an issue open for this for a little while. It looks like it hasn't had a ton of progress, except I think me giving a thumbs up because I'd like to see this. So, because I don't have a lot of other stuff to talk about right now, I'm going to take a look at how this works and see what exactly that would take. So where is the mini dump stuff getting done? Is that in the PE stuff? Yeah, that's in the PE stuff. So what are they doing here? I forgot. I have all this pulled down. So the Python version of this took a little over a minute and a half to run through, which isn't bad. And we're still waiting on the full exploration one. Tools, Manticore. So if I come in here, where are we? So there is a model for Windows that will do that. Okay, let's take a look at that. Manticore / binary / init. We've declared a class which is a mini dump. We will potentially load it in. That seems relatively straightforward. So there's this function. They've declared a class here. So for anybody that wanted to actually watch useful things they might learn something from, feel free to stop watching now, because now I'm going to poke around with some of the internals of Manticore and see how hard it would be to jam loading a core file in here, which, depending on what exactly it is you're interested in, this next part might be pretty boring. It's probably going to be a lot of me going, what is that doing? What is that doing? Oh, I guess it's doing that, isn't it? Which there's probably a decent chance isn't going to be that interesting to a lot of people. So if that's your cup of tea, feel free to keep watching. Otherwise, I'm going to take a look and explore the internals of Manticore and see where we get. So there was that in there, and there was also in the PE. So binary PE. There's also in here. Where in here was it? My phone is doing stuff. What are we doing here? So we init. Okay. Nope. I cannot switch tabs that way in Firefox, can I? Unfortunately, a little bit more complicated than I was hoping for. I guess it isn't too bad. So there's a few hundred lines to parse a mini dump, it looks like. And then whatever this code over here is doing to actually do something with it. So if we're just running this, we try and load the binary and dump out threads and maps. So here's the elf class, right? So the elf class, what do we do with that? So we are inheriting from binary, we're calling it, initting it with that. We have a mini dump. Did we import this already? Get this. How do we get a mini dump? Grep dash r mini dump. So we imported it from. We will import it from binary PE. Imported this. A model for Windows. Model for Linux too? Presumably there's a model for Linux, right? But it probably is not in the model Windows folder. Probably in the model Linux folder. That would make sense, wouldn't it? So where did we actually use this thing? So we imported it here. It should be moved to a load dump or load state function. It's a little interesting that they only support x86 on Windows, or at least the mini dumps only support it, because they're doing this assertion here. It would mean that if it's anything else, it's going to fail hard. It looks like it does the same thing here when it loads it. How does that work? So this, I think this is being declared in two different places, isn't it? We have one class there. Oh, that's the inline class. How does that work? So we imported minidump. Minidump came from / binary / pe / minidump. We imported this, and somehow it uses this to have a capital minidump. All it does is declare some classes. That's odd. And let's go check on our other stuff real quick. So we had that. Wow. So the Python version where we directed it took. There's a git grep. I didn't realize there was a git grep. So apparently I can do a git grep, which will grep all versions files. Interesting. I did not know that was a thing. It looks like I've killed the other window that I had that in. But we took 1 minute and 38 seconds to do the directed version of it, as opposed to a little over 4 minutes for the undirected version. So it turns out writing some Python to tell Manticore where to go is vastly more efficient. It's what, about a third of the time it took to go do that. So quite useful. Plus, it gave us the real information rather than having to dig through the core files and figure out where we were. So, where are we? So we have this mini dump class, which accepts a path. And if I assume that that is... Okay, I need to clean some of these up. Exit, exit, let's just kill all these. Ooh, exit. Enter tools / Manticore. No. Manticore. There we go. Much better. So, where were we? We're going through here, and we said that, where was that being declared? That's not what I wanted at all. So we declare it in binary. So this is the only place where we're declaring a mini dump. We do pass a file name, and this is going to, I'm so confused with how this is getting set up then, because we call mini dump. Oh, capitalization is hard, isn't it? So I am not currently solving anything from a CTF. Right now, I am poking at the internals of Manticore. Basically, we're just trying to learn a little bit more about how Manticore works on the inside. Maybe trying to shoehorn in a little bit of for dump functionality. But that's maybe a little bit of a stretch. But there is a little bit of a description now in this file. Yeah, we're not currently looking at a CTF anymore because there wasn't anything this past weekend and there's nothing coming up this following weekend. So instead, I'm kind of just getting a better handle on how a tool that I would like to use more works on the inside and maybe doing a little bit of development on it to make it a little bit better and do a little bit more of what I want it to do. So that's the plan at least. We'll see how that works out. Oh. Oh, nope, that is not what I wanted at all. I was typing in the wrong window there. So, Manticore binary mini dump. Hate when I do that so much. There we go. 467. So we do declare one in here. Ooh. Okay. We're going to pass in here. We're going to open it. This is where we're actually parsing it. Okay. So we had mini dump, the capital D, which is what's actually parsing it. A filter for printf call that would not go that path if its first argument is a filter for printf. I'm not actually sure what exactly you're saying. A filter for the short application that test.c, or with what I'm searching for. In any case, I'm going to keep looking at this. So we have our thing here. We went down that path in binary. Okay. So how do I actually use a mini dump? An example about how to use a mini dump? Maybe that's a good place to start. Here, there is in fact not. If we we'll import it there. There's a parameter in this, which is a path to mini dump. Well, it does not look like exactly what I want. That might be what I want. Oh, yeah. So disconnected is saying one thing that you could do is um, to filter that out so that it just wouldn't go down that. Um, Something else that I've done. So when I was playing with it earlier being a week or two ago, one thing that I did was I just used Binary Ninja and I just automatically went through and said every printf just nop out. So I just wrote a quick script. Believe I put up here just as a stupid simple way to do that. I wanted to go through and just wrote a quick function to open up in Binary Ninja the file. I then want to find all of a specific symbol, and every call to that symbol, I want to just convert to nops. Super simple, worked fine. And then I wanted to nop out all of these functions. I wanted to nop out the alarms, printfs, puts, putcar, fputs twice for some reason. Not quite sure why I did that one. And as well as the call to set buff, which is setting up some of the buffering options that a lot of CTF challenges have. For when you're piping it over a socket, they do set buff to change the buffering on it, so it works a little bit better. But, where were we? So, if we come in here, I want to see Manticore binary init. Sure. Yeah, I have personally found Binary Ninja super useful, not for the disassembly as much. So the disassembly, I mean, it's pretty usable, especially when you turn on some of the low-level IL stuff. Like, this is pretty readable. But what I found so useful about it is anything that I would normally write in IDA Python is almost certainly easier to write through the Binary Ninja API. Because while I can do something like I already closed it. Well, I could totally write something like this in IDA Python. It would not be as easy as just looping through everything and just writing into the binary and saving it. In fact, I'm not actually sure how to do that from the API. Like if I could entirely do that from the IDA API. If you're familiar with the IDA API, it is huge and convoluted, and I kind of want to say it has a surprise ending because every time I think I know how to do something properly in it, I'm wrong. Um, but doing it in Binary Ninja was super simple and quick. This script, for anybody who's curious, it's basically I want to take in a binary. I want to then patch out a whole bunch of functions that I don't really care about. And then I want to get a list of all the calls to, in this case, it was calloc, because the intention here was I would go through, I would pre-process a binary with Binary Ninja, get not only a whole bunch of patches into it, but also find all the calls to a heap function, malloc or calloc. And then what I wanted to do was I wanted to have a Manticore script to, for each of those calls, hook it and try and figure out if I could make the binary malloc a fast bin, a small bin, a large bin, or an immap. Basically just for heap exploitation reasons, which bin something that was allocated ends up freed into. So there's the 4 major bins that dlmalloc in the glibc dumps things into. What I wanted to do was I wanted to be able to pretty simply figure out, could this binary dump something into each of those bins? Unfortunately, this script doesn't work. I'm not quite sure why. At some point, I'm going to revisit it once I understand a little bit more about why it doesn't work. I suspect the answer is with some of this solving stuff. But we'll see. So, Where were we? Going back over here and getting a little bit less diverted. So we had, oh, there's a binary magic, which, well, that is not what I want. Well, that is interesting. So your pull request is even more useless than expected. What is your pull request? It may be a pull request opened 2 minutes ago. Oh no, how do I view this? Oh. Yeah, I have no idea why I was patching it twice. Um, I suspect it's just I copied and pasted too many times and never bothered to fix it. Uh, but I really do enjoy the troll pull requests. One thing that I've threatened to do for a while and have never actually gotten around to doing, and to go off on a complete tangent here now, um, so I want to def function or fun, no arguments, a is equal to, or let's pass in a. If a, we want to do this other thing, else print live long and prosper. And then we want to just call fun one, right? Super simple. What is, oh, good. I'm glad I'm doing this in the, in my Manticore directory. Set no auto. Right. So one thing which I like to use to blow people's minds. 1, 2, 3, 4. Oh wow, I have 8 spaces to a tab turned on in this? Huh. 1, 2, 3, 4, 5, 6, 7, 8. No, that did not work the way that I wanted it to work. Oh, do I have to do it the opposite direction? Hmm. Oh, has this actually been fixed since the last time I did it? So there was a situation at one point where you can mix tabs and spaces such that that Python got incredibly confused and would still work. But apparently, I can't anymore. That's unfortunate. Because there are some weird things you can do with indentation in Python, which lead to code that doesn't quite do what it looks like it does. And I wanted to write a bot to go through GitHub and try and process all of this and spit out the most confusing looking Python code that still did the exact same thing. In particular, using the tabs and spaces and mixing them up together. But it looks like the way I was doing it before is different, and maybe I'll look at it later and do it again. But the short version is writing a bot to go into GitHub, find things, make code more confusing, and then submit a pull request and see where we got to. So as far as trolling goes, it's something that I appreciate quite a bit. Where were we? Yes, submit pull requests to reformat your code in ways that are more confusing. I kind of want to write 2 different bots to switch from tabs to spaces and spaces to tabs. And if you ever accept the pull request from one of them, the other one fires and tries to switch it back. You know, stupid things like that. So back to something that's maybe slightly useful. How do we actually do this? So if I say Manticore, I can supply a mini dump. Right? Right? Maxim data end policy dump after max storage max speeds. Timeout replay coverage error. How do I set that up? Search through here for mini dump. What do you have to say about this? How do I actually call it? This. Now, so this describes that. Thanks. It it tells me to ignore this. I am going to do the exact opposite of that and see where I can get. I do like the here are some instructions on things you should do. I'm going to ignore that anyway. What does this do? Make windows as expected args to be populated. Args is typically set button there. Well, I have no idea what that's doing. So why did it tell me that? Yeah. Ooh, run simple. There we go. That may actually tell me how to do this. So example. Run simple. That's not what I wanted at all. That's unfortunate. Oh, so if I pass in a mini dump, it's going to automatically figure that out? Is that how that's supposed to work? Let us go find that out. We are importing Manticore. Ah, it helps I can spell Manticore. There we go. The central analysis object. Okay. We have a binary path. Oh, is that how we do it? That's interesting. So we call, if I do this properly, Python ctags. That's not what I want at all. I want to do this one. I want, wow, that is a lot of arguments. Do I really want all those arguments? Can I just do dash dash languages Python? Tags dash r dash language languages Python equals Python. Oh. Real-ish. Oh. I want to do it in this directory instead. Yeah, that looks great. See if this works. Oh, it does work. Look at that. How useful. So this is hard coded to determine what the binary type is. So I would need to fix that. Let's do the other piece of this. So if I go again, how do I? G core. We now have a core. There we go. So unfortunately, this has the same header as, I mean, it is an elf, right? That kind of makes sense. Can I actually just do that? So core dump is essentially an elf. So can I really just do a core? That's just work? That does not work at all. Okay. But, so the returns it itself because it is an elf. We then dump that over there. We say that there are workers. Workers will be removed soon. Exists currently to ease portions, model hooks, running arch manager. If it is an elf, we will file. What is elf file? So from elf tools, import elf file. Where did we crash when I tried to very naively parse this thing? We tried to load. Oh, we tried to load an entry point. Okay. So that's something interesting, right? That because a core dump is essentially a elf itself, which is telling. So a core dump is very similar to an elf. It's just it has an extra section with register state, and otherwise, I think it's the same thing. So what are we doing? What on earth is elf tool? I have no idea what elf tool is. Start with that. Python elf. Yeah, look at this. Elf tools. Same elf tools. Python elf tools. Elf. Yeah, this looks like a thing. Thing do. Elf port. Looks like that works relatively well. So there is a construct. Oh no, this is a core. This is the core of it, not a core dump. Uh, Elfmaster ECS. ECFS. That. Elfmaster / ECFS. Huh. Extension for the existing elf core format in Linux. Job is to intercept the core dump handler. Core dump. It is. Huh. Hmm. An ECFS file is not limited to just elf program headers, but also contains many section headers as well as fully reconstructed relocation symbol tables that reflect the state of the code and data in runtime. Hmm. That's interesting. So, right. So a core file is an extension of an elf, and an ECFS is an extension of a core file by permitting extraction of information about the mapped data sections and register state. Basically, what I want to do, if I want to make all this work, is I would like to be able to specify a core. So I would need to modify how we're parsing elves. It looks like it's actually relatively complex, right? So they're offloading the elf parsing to elf file, which is this. No, this. Let's take a look at this thing. What exactly is this thing? Like, can I get away with just passing in something slightly different and getting register state? If so, that'd be great. Mm. This does not look like it does what I do. Fortunate. Um. Okay, so but we will load like that. Oh, no, do not change itself. Where does that get used? Grep. A grep, not a rep. Binary obj. Where is this thing getting used? So we load it. If it's none, we do that. Assume else, we do other stuff. Of course. Hmm. So if well, we also have this. So we have a make state. Elf, we do that. If it's a PE, we do that. If okay. Hmm. This is not what we care about, right? So this is actually creating all of that, which I don't think we care about. Okay, let's go back to how a mini dump works, right? So we had a mini dump. It had magic. Where does that get used? So grep rn mdmp. That gets used in two places. Well, three places. So it's set up there, it checks it there, and it over there. So it's a wait. So does Manticore not handle a PE, but does handle a mini dump? Is that what I'm reading? Like, am I reading that correctly? It won't parse a PE, but it will parse a mini dump. At least currently. That's interesting. Oh. So these are two completely different paths to doing pretty much anything. Given that elf stuff parses out using a library, the mini dump stuff, looks like they wrote their own mini dump parser. CD Manticore binary PE. Yes, I don't care. Yeah, it looks like they wrote and or did not keep a license at the top. Huh. Looks like it might actually be a little bit more complicated to get this all shoehorned in than I was hoping it would be. So I guess at this point, we're about the hour and a half mark. And I don't think I'm making any useful progress for anybody watching, other than maybe some of the developers seeing somebody else poke around in their code base. So I think I'm going to call it an evening about now. For people who tuned in later, there's a couple things that I think are important. One is that on Wednesday, I will not be streaming like I usually do. Instead, the Wednesday 0 day stream is going to be on Saturday afternoon. Well, Saturday afternoon, my time. I believe the current plan is to stream at 11 a.m. Eastern, which I believe is 3 a.m. UTC. At least that's what Google told me. That's a plan to do that on Saturday, because I have some other commitments on Wednesday. The plan then is to start looking for Python memory corruption bugs. So we're going to be going through trying to first replicate a Python memory corruption bug that somebody posted about publicly, write a basic test harness to be able to catch crashes in Python, and then write a fuzzer, a generative fuzzer, to try and find that specific crash, and hopefully other ones too. Ideally, we're going to be able to find a whole bunch of different crashes throughout some of the Python libraries. I think the first thing we're going to take a look at is NumPy, because that's where the crash that started this was. We may expand that out to other things. We'll see how things go, but I suspect the first week of streaming of that on this coming Saturday, it's mostly going to be laying a lot of the groundwork. So trying to create a very basic test harness, a way to, we're going to create a single test case, so a function to a fuzzed function, then evaluate that, see if it causes a crash. If it does cause a crash, we want to record that output. Otherwise, we can throw it away and try again. We're going to have to write a simple test framework to be able to do that, and then write a generative fuzzer to try and generate functions which will evoke this functionality that causes the crashes. That's the plan. I'm not sure exactly how far we're going to get on Saturday or how long I'll be going. I'll probably tweet out before I start, and then again when I finish up on Saturday. The plan, though, is for it to be longer than most of these evening streams have been. So usually I've been doing an hour to 2 hours Mondays and Wednesdays, mostly because at some point I need to get to bed so I can wake up in the morning and go to work. But on Saturday, I can probably go for maybe 3 or 4 hours, depending on how long my voice holds out. Hopefully we'll get something useful out of it. What I'd like to see is basically talk through how you would write a generative fuzzer, why you would want to, the kind of things that might look at. So the reason we're looking at Python is because it's similar to a lot of the interpreted languages that are popular targets for fuzzing, or at least they were historically. So Python is at least somewhat similar to JavaScript in that it's an interpreted language that has something backing it. The big, huge difference is that where a crash in JavaScript, like if I was fuzzing a JavaScript parser and I got it to crash, especially in an exploitable fashion, I almost certainly do not want to do that on stream. That has some ramifications that I don't want to deal with. However, if I do it to a Python library, those ramifications are almost non-existent. Because realistically, if I can run arbitrary Python in your system, you're probably already screwed. As opposed to, if I can run arbitrary JavaScript in your system, you probably went to my website. So, in any case, that's the plan for Saturday, is to try and find some Python memory corruption bugs and see where we can get. Other than that, trying to think here. Like I said, I'm going to post about that on Twitter. The plan is to go for at least 3 hours, and I'll definitely post when I finish too, in case people want to tune in someplace in the middle. Expectation is to go for a while. We'll see how things work out. And other than that, I will see everybody later. Thanks everybody for tuning in. Bye.